Today we're doing Pythagorean Theorem Part 2, Unit 3, Day 8. Our objective is I will be able to calculate the legs and the hypotenuse of right triangles using the Pythagorean Theorem. So a prime number is a whole number greater than 1 whose only factors are 1 and itself. A factor is a whole number that can be divided evenly into another number. So examples of prime numbers are numbers like 2, 3, 5, 7, 11, 13, and 17. If we take the number 5, for example, and think about what are all the numbers that I can multiply and get 5, you only end up with 1 and itself. There are no other whole numbers that you can multiply to get to 5. Now, prime factorization is a process of finding which prime numbers multiply together to give you the original number. So if we look at the number 72, for example, we found what are some factors that break up and give us 72. So we thought of 9 and 8. Well, 9 and 8 aren't prime numbers, which means you have to keep going. So what are numbers that give us 9? Well, 3 times 3 equals 9, and 3 is a prime number right here. So we circle those 3's, and then we go back to this 8. Now the 8 we need to also break up because it's not a prime number, and we get 2 times 4. 2 is a prime number, as you can see up here on our list. 4 is not. So 4 we have to keep going. We break that into 2 and 2 as well. So we have 3 times 3 times 2 times 2 times 2, which is our prime factorization. Now our first teacher example is going to be to simplify the radical square root of 40. The first thing we have to do is to complete the prime factorization for 40. So what are two numbers that multiply and give us 40? Well, we have 4 and we have 10. Neither of those numbers are prime numbers, so we have to keep going. So 4, we end up with 2 times 2. 10, we get 2 times 5. So the prime factorization is 2 times 2 times 2 times 5. So I'm going to take that and put it underneath our square root. 2 times 2 times 2 times 5. At this point, we just want to circle any pairs. So I have that 2 times 2, right? 2 and 5 here are different numbers, so we're not going to circle that. Our circled pairs we're going to put in a separate square root. 2 times 2, and then 2 times 5. Now the square, 2 times 2 is 4, and then 2 times 5 is 10. Well, we know what the square root of 4 is, right? The square root of 4 is just 2. So 2 square root 10. Because when we take the square root of 10, you get a very long decimal, and we don't want that. So this is our final simplified answer, 2 square root 10. Try your first student example below. All right, our second teacher example is going to be to determine the length of the missing side and write our answer in simplest radical form. So we start out by looking at where is our right angle, and we know that the side opposite the right angle is always going to be C. From there, we can label our A and our B. And we know the Pythagorean theorem states A squared plus B squared equals C squared, where A we can replace with 6, and B we can replace with 3. So 6 squared is 36, 3 squared is 9, which equals C squared. You add those together, you get 45. Now from here, we want to get C by itself, so we have to undo the square, so we take the square root of both sides. C equals the square root of 45. And now we have to go through the process of simplifying this radical. So we're going to do the prime factorization for 45, and you get 9 times 5. 5 is a prime number, so we're going to circle it. 9 is not, so we're going to break that into 3 and 3. So the prime factorization for 45 is 3 times 3 times 5. So we have the square root, 3 times 3 times 5, and there's our pair. It's going to be 3 times 3, and the square root of 5, which is square root of 9, square root of 5. And we know the square root of 9 is 3, so our final answer is C is equal to 3 square root 5. Take some time and try student example number 2, please. Now for your summary, make sure you're writing 3 to 5 sentences to summarize your main ideas. Make sure you're looking back at the objective and that you're using the proper academic vocabulary. See you guys in class. Bye-bye.